So hopefully you're in the right room. This is Multimodal Interaction and Interfaces. Today's lecture is about extended reality. My name is Renan. I'm a postdoc here at KTH. I'm from Brazil. I did my bachelor's and master's in computer science back in Brazil, and my PhD also in computer science in Australia at RMIT. I've been working with augmented reality and developing things in Unity for quite some time now, doing HCI research, working with VR, haptics, data visualization, assisted technology, so like a bit of everything in novel interaction platforms. So today I wanted to talk a little bit about different nomenclatures that we use in the literature on extended reality. So what are the differences between extended, mixed, augmented, virtual reality? Some of you might know already, some of you might have some idea, but for other people it might not be too clear. And then there's also other terminologies that some people, some companies end up using, like spatial computing, the metaverse, immersive experiences. There is some debate, not necessarily debate, but there's some mismatching, like what certain people or certain companies call specific experiences. So I just wanted to talk a little bit about that today. At the end of the day, just be the main takeaway message today is that these discussions are purely semantics, like they're purely semantical. So it's all about the meaning of the words that you're using. So if you are talking with someone and you know that you are talking about the same thing, you might as well call it whatever. You know, like you know what you're talking about, so that's totally fine. This is more about if you read something or if you're talking to someone you don't particularly know, then you get to use not necessarily the correct, but the most used nomenclature for these types of things. So in academia, this is the most well-accepted spectrum for defining these things. Has anyone ever seen this before? It's the reality virtuality continuum. No one? That's totally fine. Yeah. So this was established back in 1999. So it's just a way to describe what a specific application is about. So on one end of the spectrum, we're going to have the real world. So like totally real, nothing virtual at all. And then on the entirely other end of the spectrum, you're going to have virtual reality. So purely virtual, nothing real, nothing from actual reality. Okay? And then in between those, but it's sort of important to notice that mixed reality doesn't go all the way to the ends, to either end. So whenever companies or whenever professors, researchers talk about mixed reality, usually they're talking about something in between those ends, but not including the extremes, okay? So what does that mean? On one end here, you're going to have augmented reality. So this means most of the things I see, most of the things I hear, most of the things I touch are real, but there's a little bit of virtual. So there's some virtual components. They can be visual, they can be audio, they can be haptics, so tactile, like feeling things. They can be even taste or olfactory, like smell. Those are not as explored as you might expect, but they still are, and they can still count as virtual or augmented reality. Okay, so on this end we have a little bit of virtual, a lot of reality. Then closer to the other end, we're going to have a lot of virtual, a little bit of reality. So if you want to be technically correct, if you want to have like a research level conversation, you're going to call this augmented virtuality, because you are in a virtual space, but you are augmenting the virtual space with a little bit of reality, with a little bit of your surroundings. okay? And that can be visual, that can be audio, all of the ones that I mentioned before. If you want to be technically correct again, you're only going to call an experience virtual reality if you have zero contact with the real world. And that is almost impossible to attain. Maybe in the future it won't be impossible anymore. But like, let's say you put on a VR headset. It's taking care of all of your vision. Maybe you can see a little bit through the edges. But for the sake of the argument, let's say you only see the virtual. You're gonna hear hopefully if it's a good experience, you're gonna hear the virtual environment as well. So if you're walking through a virtual forest, you're gonna hear birds, you're gonna hear your footsteps in grass or mud or whatever. So that's also gonna be virtual, right? So up to now, we are qualifying for fully virtual reality. But let's say I'm in my virtual reality glasses and I'm walking here and I touch this thing and I feel this thing. And this thing is not in the virtual experience, right? It's part of the real world, but it's not part of the virtual experience. It wasn't supposed to be there according to the people who developed it, right? So in this sense, and at the same time, someone might walk by me like a real person and I might hear them speak. And that's also real world, right? So then you get like a little bit of a disconnect between what your experience is supposed to be, purely virtual, and what is happening around you. So if you want to be extremely technical and correct, you would not use the term virtual reality for current VR experiences, okay? However, if you want to be a regular person, have a conversation with anyone else, you're still going to use virtual reality. You're just going to have that in mind. Okay, like, it doesn't fully qualify, but like most people are going to accept that it's still VR, you know? When we talk about augmented virtuality, we're usually talking about experiences where, let's say, I'm in this virtual world, and then somebody walks by me and they want to interact with me. If my headset, if the system that I'm using has a way to acknowledge, okay, someone is trying to talk to my user, I'm gonna let a little bit of my visual get through, and that's what we usually call a pass-through. And I'm gonna allow them to see that person. So the real person that is there with me, I'm seeing them, but then all around that, I'm seeing the virtual elements, okay? So that would qualify, that is standard pristine augmented virtuality. Okay, so that's like a good example for that. On the other end here, augmented reality, most of you might have at least heard of what it means or seen examples. Usually, back in the day, like almost 10 years ago, the best example that most people knew of was Pokemon Go. You like get your phone, turn on the camera, and you see like a little Pokemon on the floor in front of you, but through the camera. That qualifies as augmented reality. Nowadays, I think the most common thing would be like filters, like Instagram filters, Snapchat filters. Like you look at yourself through a camera and you see like elements, I don't know, like dog ears or makeup, whatever, show up in your face. That is also augmented reality, right? Because it's augmenting the reality, so yourself, right? So those are very decent examples. Just to explore it a little bit more and to have a discussion with you guys, I'm going to go through some examples of projects. Most of these I've been a part of. And I want to ask you guys where would you place it in the spectrum? So let's say if we have a spectrum and if we understand everything, all the concepts that are here, we are going to be able to place something like a very specific application along the spectrum, right? It doesn't need to be precise, but like we're going to have a discussion about it. So I wanted to use one of these, but I'm not sure. Can you see like the bottom of this thing? Other in the back, you can? Yeah. Okay, so I'm going to use this, otherwise it's going to be tough for people in the ends. So let's do I'm just going to replicate the spectrum here. So from one end, can you read this? You can? Okay, good. On one end, real world. On the other end, virtual. What do you say, virtual reality? Could be virtual world as well. So encompassing most of it, we have MR, so mixed reality. Then here we would say AR starts, and here we would say AV starts, or AV ends. And of course, in the middle, it's a blur, but like we're gonna have a conversation about it. Oh, it's here. So some applications. This one is kind of like almost equivalent to a Pokemon Go. We were studying like the perception of empathy using augmented reality, and you're looking at a real table in front of you, and you see a little character. The character doesn't move. You're just standing there. This is like a psychological test, by the way. The character doesn't move. They're just standing there, and there's some virtual elements there, like a little gun and a rose or a flower. And in this case, you're supposed to tell the experimenter whether the gun is to the right or the left of the participant, in a way to understand if the participant can place themselves into the head of the virtual character there, okay? But just for the sake of the argument today, this is what you'll be able to see. Unfortunately, I don't have a video for this one. I have it for most of the other ones. But it doesn't move, it just stands there, but it's still lifelike, like it's the size of a real person, the table is the size of the real table, and so on. So where would you put that into the virtuality continuum here? Any opinions?
Like which part of the object is virtual in that?
Oh, okay, yeah. So the floor is real. There's a real table there, but it's being occluded by a virtual table. The character is virtual. The flower and the gun are virtual. Everything else is real. So where?
Argument is reality.
AR? Yeah. Anyone else disagrees? Anyone disagrees? No? Very standard example of AR. Completely agree. Yeah. You see, of course, this is just like a snapshot. Like you'll be seeing more than this, but like you see the room that you're in. You just have these small elements as virtual. So yeah, let's say then number one is here-ish. So very standard AR, sorry. Very standard AI use. AR, or next one. I'm gonna let you see it first and then I'm gonna explain it. So this is a first person view, of course. And that's the participant there. So you already have a pretty good idea of what they're wearing and stuff. You might notice there's something on her arm there. So this application, we made it for a interaction contest where the theme was to explore digital empathy on people with different conditions. So we chose to work with amputees, so people who have like an amputated limb, and the phantom limb sensation. Like, just in case you don't know, if you have an amputated limb, a lot of times you still feel like your brain feels like you still have the hand that is not there anymore. Sometimes you feel pain in it, sometimes you feel like you can move it, but of course it's not there anymore, so it's just a mismatch between what your brain feels and reality, right? So we're trying to give that feeling to people who don't have that condition. So to accomplish that, what we tried to do was, first of all, we put a force feedback device on the person's elbow there. So that thing has two motors. One forces your arm to move like this, and the other one to move like this. So on two axes, right? And what we're doing there is tracking where the person and their arms are at the entire time, during the entire time. And we have a real table to, I guess I could use this to explain. So let's say to the right of me, I have a real table. To the left of me, I don't have anything. But the person, they are in VR, so they are seeing an entire virtual table. So if they try to touch this table, they still have this arm. They look at it, they have the arm. They touch it, they feel it. If they try to do it the same with the other arm, it's going to go through because there's nothing here, even though in VR they feel like it does. And if they try to touch it with the part of the arm that they see is not amputated, so the part of the arm that they still have, then the motor, the haptic device, the force feedback device, it pushes their arm back to sort of create that understanding, that feeling that the table is there, right? So where do you think this experience would be placed in the spectrum? Anyone? Yeah?
Maybe much more towards the AV, because they can actually see the room, but they can interact with some parts of reality, still like the table or the object.
Anyone agrees or disagrees? Agrees? Anyone disagrees? Yeah, I agree as well. What you said is perfect, right? Like they can still feel some parts of the real environment, even though we're trying to replicate haptic feeling. So haptic is like tactile, right? Even though we're trying to display haptic feelings that are virtual, they still have access to a lot of the physical, the real. So yeah, like just on top of AV, I would say that's probably really good. So we can place number 2 here. Okay, next one. So, okay, I think this one had sound, but we don't need to listen to it. So here we were looking into data physicalization. So what does that mean? There's data visualization, of course, which is what we usually do, like you put data in a graph and you understand it. Here we were trying to explore a sense of haptics, so tactile, to display data. So here we were looking at COVID cases, so like this was on the height of the pandemic. We were looking at the numbers of COVID cases per country. And we were trying to display that with vibrations. So the harder the vibration or the more frequent the vibration, the higher the number we're trying to convey, right? So if we had this little map and the person would feel around with the computer mouse, and with all of these actuators here, one per finger, we could display to the user exactly where the mouse, the cursor of the mouse was, and everything next to it. So let's say the index finger represented where the cursor was. Everything to the left would be the area to the left of the cursor, and the thumb would be the area to the right No, sorry, the opposite. Right, damn, left and right, yeah. So if you cross from one country to the other there, you would feel the vibration change, and you'd feel it exactly in your finger. So you could feel exactly the border in one finger, then the other finger, then the other finger, right? So we're trying to convey data through a sense of haptics, vibration in this case. Just then we were talking about force feedback, which is one type of haptic feedback. Another common type is vibrotactile, so vibration. And of course, in this case, the user is looking at a computer screen, so it's like a 2D regular screen. Now, where would you put this in the spectrum here? Yeah?
Maybe just in between.
In between?
Yeah.
So like the middle? Okay. Do you have any reasoning?
Well, we just have both elements from the reality and virtuality.
That's fair, yeah. Anyone agrees or disagrees? Yeah?
It feels kind of like the real world, but with just some haptics to it in one way. Then you're looking at the screen, of course, but it's more like almost between real world and AR, I would say.
So you would place it here,
Maybe, I think so.
and our colleague there would place it here, right? Raise your hand if you agree with this. Raise your hand if you agree with this. Okay, we have like a 50-50. That's pretty cool. Okay, so there's a case to be made for both arguments. I think both arguments are very sound. But then I would like to propose something. Like you mentioned, like, okay, there's the screen, but then the only thing you're feeling is some haptics, right? Why is there any reason why haptics is less important than visuals? You know, like it's an argument to be made. You could say that it is, like most humans, I mean, almost every human is very visual, like we care about visuals a lot. Of course, some people are visually impaired. They either have a limited amount of vision or they have no vision at all if they're totally blind. And then for those people, they would probably disagree with you, right? Like, okay, like why is visual more important, right? If I can't see. So there's an argument to be made there, right? So let's say out of the 5 senses that we have, 1 is visual. The other 4 are different things. 1 is tactile, for instance. So if we were to say, okay, like we're taking care of haptics here, we're taking care of tactile, that's 1/5 of our senses, right? So why is that less than visuals if visuals is also 1/5 of our senses, right? So there's an argument on both ways. I also agree that haptics in general are not seen as important as visuals because we are very visual. So it's a discussion to be made, you know? I don't think either is entirely correct. I think it really depends on what we're looking at. So, yeah, but I think both make sense. So let's say somewhere down the middle. So first student said here, the second one here. So let's say somewhere here, right? So let's do a 3 here. Some contention, but it's a middle ground. Now sound. Sonification. It can be a bit of a weird thing to address. I'm trying to pause this. Okay. So sound in the literature for interfaces, it's usually split into 3 different things. One is speech, so talking, very straightforward. One is music. Most people understand what music is. And the third is sonification. So sonification is manipulating sound to represent data. Usually that's what it means. So if it's the distance between sonification and music can be very blurred if you are not a very musical person, because music it's about like entertainment in a way. I mean, it's art, of course, but the distance between a noise and music can be discussed, right? Like you might appreciate one more than the other, but someone else might appreciate what you would call noise. So the discussion can be a little bit blurred, but sonification is manipulating sound to represent data. Okay, there's some efforts in exploring something called musicalization, which is like musifying sonification. So exploring sonification more in a musical way so that it can be entertaining as well. But that doesn't matter right now. So this work here, we're exploring. Oh no, there's sound. Okay, it's very low though, but that's okay. Oh, what happened to the video? Oh, sorry. Okay, yeah. So we here were exploring sonification methods to represent spatial data. So specific locations in the world around us. So for this first one, we're talking about 2D guidance. So we're exploring this with BVI, by the way, is blind and visually impaired people. This person here was a visually impaired person. So in this experiment, we were looking at displaying targets to people who couldn't see, of course, using sound. So we're mapping things like the pitch of a sound, the tempo of a sound, volume, stereo, so like if the sound is coming from the right or left, harmonics, so we also got a little bit into music, but that's pretty much what we're doing. Okay, so just so you know, in this case here, the person is controlling the movement only with a mouse. Okay, so this was the experiment actually. So they didn't see the target there, of course, but you sort of hear the sonification, and you're just moving a mouse around, trying to find the center of the target. Okay. So where would you place this in the spectrum? Anyone? There's no wrong answers, by the way. Like it's as you saw before, like everything can be argued. No one? Yeah?
Well, I would put it as AR.
AR. Any reasoning?
Well, because it doesn't actually like add anything. I mean, it's just it has the actual like data in the real world.
Fair enough. Yeah, fair enough. I think you raised your hand as well.
Yeah, I think it's very similar to the previous one. It's now it's sound instead of haptics.
Mm-hmm. And where would you place it then?
I guess we're back in the same kind of situation.
You'd have the same opinion.
Yeah, but like if it's in that. Yeah, exactly. Yeah, probably. Or maybe I want to move it slightly more to the right after.
Mm-hmm. Okay, so you agree a little bit more with the colleague. Okay, cool. Yeah. I guess, let's say the same position then. Anybody else disagrees or agrees? Yeah? So people agree. Okay. I think that's very fair, yeah. So this one, we were only looking into 2D guidance. So the space that you could move in was only in 2 dimensions, so the same movement that a mouse does. And for that reason, I would say we are slightly more towards the real here because you don't have that much more to explore. It's just 2 dimensions. But then in the next case here, we did a similar thing but for a 3D environment. So now the person is wearing a headset because you need to track the whole environment. So the headset now acts sort of like the mouse was before, right? So the headset you can move in 3 dimensions because you walk around, you can go down and up. And in this case, we're exploring targets in a real cupboard, which we're gonna see now, I think, yeah. So the whole cupboard from the floor to the ceiling had a bunch of targets. The person is listening to sonification as well. And they're being guided from where they are currently to the target that we're trying to guide them to. Okay, so it's a very similar experiment to the previous one, but now it's 3D, and now it also uses a real space around them, the cupboard. The sound is similar to the one before, so there's not much you're missing. Now, where would you place this? Yeah?
I think it kind of goes against what you just said about it maybe being more like to the left if it's like less representative of the world.
Uh-huh.
But I think this is further left because
Mm.
it's more of the reality
Mm-hmm.
coming through. Whereas the other one is more virtual because it represents an alternative reality.
Mm-hmm. Cool. Anyone agrees or disagrees? Yeah?
She's seeing something.
So this participant, she was sighted, which means she's not visually impaired. So she's wearing a blindfold.
Okay.
So she's not seeing anything, yeah. Does that change your...
Yeah, I need to think.
Fair enough, yeah. With this information, would that change it for you or...
Maybe. But I think they're very similar. I don't know if adding a dimension you can move in necessarily alters maybe it alters the immersion in a way, but I don't think that scale really talks about immersion, because then it's like 1/5 of a sense. Is that just, how should we kind of distribute that?
Mm-hmm.
But if sound or like the hearing is her only way of navigating, then and that's virtual, then I would say that the virtual world is more she's more in that than in the real world. Or she's playing by the virtual rules more.
So you're saying we're more towards the VR, is what I understand? And you're saying we're more towards the AR?
I think they're very similar in a way. It's just like it's 2 dimensions or it's 3 dimensions.
Sure, but about this case here, the 3D one.
Yeah, maybe a bit more. I agree with that, but I also kind of feel like she's moving very much in the real world. So it's closer to the real world versus like moving a mouse. It's a very virtual representation of that.
Cool. So let's say then we're between here and here-ish, according to different schools of thought. Who agrees with the left one? VR? VR? Anyone else? And who agrees with the AR? Okay, a little bit more people for the AR. Okay, so my opinion here, I actually added there audio only. Is it AR or VR? Because it can be interpreted in both ways, right? Like, okay, the audio is virtual, but the audio is a representation of the real. So, like we're using a virtual thing to guide you in a real space. So it can be also the lack of visuals can make us a lot more confused, right? Because okay, we're not seeing anything virtual, but at the same time we're not seeing anything. So does that where does that place us, right? So it is an interesting discussion to be had. That's why I included this. And you're actually right. I misspoke before when I said the previous one was. Let me go back. When I said the previous one was more towards AR, I misspoke. I meant it was more the other way, because it's more. There's less connection with the actual environment, right? So it's a bit more towards VR. So yeah, I actually agree with that. So let's say number 4. I mean, I still wouldn't place all the way on VR because you still see a lot around you. It's just that, I mean, I guess the experience itself is purely VR. It's just not immersive, correct? So you actually introduced something that I wanted to talk about. This thing, it doesn't encompass every possible experience, because there are things that we miss here, and one is the immersiveness in a way. So some people would argue, and I've seen works that do this. They suggest like another axis. So this is the x-axis, and they suggest another axis. And of course, for the sake of their argument, they're going to propose different things for the other axis. But one thing could be immersion here, and then like I would totally agree with you. At the same time, and this might be good for us to come back to the beginning when we were. How are we on time? Okay. So VR, if you ask an HCI person, a human-computer interaction person, especially people from computer science, they're going to argue that VR needs to be immersive. It needs to be fully taking care of your senses. If you ask people from educational sciences, sometimes psychological sciences, they're still going to use VR for non-immersive experience. So they're going to call a regular computer game, like, I don't know, like a Counter-Strike, they're going to call that VR. But then they're going to make another distinction. They're going to have the term immersive VR for things that are immersive, and regular VR for things that are not immersive, you know? So again, it's a semantic discussion, you know? So as long as we understand each other, it's totally fine if we call it VR or not, you know? You just need to know who you're talking to. So it was a good call there to mention the immersiveness. So going back here, okay. So this is this one, I would say it's like almost a non-immersive VR, right? So let's say if we had another axis here for immersiveness, then it would be more towards the lower end. So this was 4, right? Because it's not immersive. There's nothing about the real environment there. Yeah. And then this one is actually an interesting discussion. If you're trying to attack the point, like if the problem you're trying to solve with the system is guiding people in their actual environment, so applying this to someone's house, like a visually impaired person with visual impairments house, and you're trying to guide them, like they ask the system, where is the pen, like in my kitchen, like pot, where is the pot, and your smart kitchen starts to play like a sound guiding you to that, right? If that's the case, if that's the problem we're trying to solve, then I would say this is fully AR, right? Augmented reality, because you're adding a virtual element to explain the world around you, the real world around you, right? But then at the same time, you could use the same method, the same sonification method for a virtual reality experience. right? If you're playing a VR game and you're trying to guide the person to a specific point, but the person is like in the dark, maybe like it's a game that you play in the dark, like in a specific level or something, or it's a game for visually impaired people, or maybe it's an accessibility feature in a regular game to include visually impaired people, then you can use this in a VR game as well, and then it's VR, right? So it really depends on what you're trying to use this for. I had another point to make here, but I forgot. So in this case, I would say for the problem that we, oh yeah, okay. And then if we are talking about a VR game, the cupboard there, it could be a prop in the VR game, right? It could be just a way to represent something. This is actually explored in a lot of works, like using regular furniture around you to represent things in a immersive fiction game, right? So let's say you're playing like Skyrim, like a medieval game in VR. You want all of your senses to be immersed. So you put the thing on, you don't see anything, but then if you touch your desk by mistake, you're gonna break that illusion, right? But then there are works that are trying to incorporate the environment around you. So let's say the headset does a spatial tracking of everything around you. They recognize, okay, this table, I'm gonna use the fact that there's a table to my right to place a table in my storytelling as well. So inside the game, I enter this room, there's gonna be, I don't know, like it's a tavern, and then there's a tavern table here. So if I try to touch the virtual table, I feel the actual table. So then this would just be a prop for the game, right? So there's multiple ways to look at it. It depends on the problem that you're trying to solve with this application specifically. So yeah, there's arguments on both ends there. So let's say in this case here, we were trying to do navigation for visually impaired people, so I'll place it more towards AR. This is fine. But then again, you could use the same for a more VR experience, right? And then place it on the other end. At the same time, this can be interesting as well. So we had number one here, and if you might not remember, number one was the little character sat in a table. There's no animations, there's nothing else. It's just visual. And in this case, it's just audio. There's no visual, on the other hand, right? So are 1 and 5 exactly aligned in the spectrum, or would you say one is more to the right or the left? Does anyone have any opinion on it? So in one case, we have fully audio. In one case, we have fully visuals.
I think if you're talking about only visually impaired people for 5, then they are perfectly aligned. But if you're talking about people that can see, then since we do usually use visual, and that's more important to us, then it will probably be less VR if it's not visual.
Okay, that's a good argument. But let me ask you, okay, so there's also a spectrum in visually impaired people, right? There's people who are totally blind, there's people who have, I don't know, like 50% vision. If you're down in the middle, would you still hold the same argument? It gets into a debate, right? So it gets more complicated than that. And that's totally fine. Like this is just like an exercise we're doing. Like there's no right or wrong here. It's just for the sake of the argument so that we understand what we're talking about, right? So yeah. Does it make a difference if it's a little bit towards the right or a little bit towards the left? No, it doesn't. If we call it AR and we know what we're talking about, that's fine. If you want to make it perfectly understandable, you could call this audio AR. The other one could be visual AR. But if you just say AR, people are going to assume it's visual anyway. So there's not that much point to debate. Okay, now moving on. Now we have a collaborative experience here. So the user there on the little square, they are in VR I'm going to go ahead and tell you, they are in VR. They are seeing, this is their first person view. And then these hands and that head there, this is very laggy by the way. The hands and the head there, that's representing a different person who is using the previous system, the audio system. Okay, so this person is visually impaired. The person on the right there is in a digital twin of the first person's kitchen, and they are communicating at the same time, like they're talking to one another. The person in the right side there, the person in the little square, they are able to place targets. They do it like here. Oh, sorry. They can place these targets, and these targets get transmitted back to the other person who are at their own house. Like they're going to place a target. Those get transmitted as a sound beacon. So that thing is emitting a sound. We're using the sound interface that was in the previous project there. So this is a collaborative system, right? So more than one person is using the system at the same time. They are seeing each other. Of course, one person is visually impaired, so they don't see, but they hear them. And the first person, in this case, it's what we call a guide. They are seeing an avatar representing the other person, right? So in this case here, we sort of have two interfaces, right? So we have one interface for the guide, and we have one interface for the visually impaired person. So we already talked about the visually impaired person, the interface. We all mostly agreed that it was done towards AR because they're being guided in their own environment. But then what about the other person there? The guide. Where would you place them?
I mean, much more to the right, AV or even further, because they are not really interacting with their own reality. They hear people, they hear the visually impaired people who's not even there, and they see their environment, which is like not his own room or not their own room. And yeah, it's AV or even AV. Yeah.
Cool. Anyone else? Anyone agrees or disagrees? Agreements? Yeah, I agree as well. Yeah. You could make an argument to say it's even more AV because even though the person that they're seeing, the avatar that they're seeing, is not there with them, they are still real. They are still a real person. They're just somewhere else, right? So you could make the argument that it's exactly AV, but I agree with you. Like for the sake of the argument, it's VR, right? It's virtual reality. It's not totally immersive for the issues that we discussed before, but it is virtual reality. Then just one thing that I wanted to add here. So we have, when we're talking about collaborative systems, we can distinguish them usually in two terminologies. One is symmetric, which means all of the people experiencing the system are seeing it or experiencing it in the same way, so it's symmetrical. And asymmetric, if they are not experiencing it in the same way. There's like some type of mismatch between the two. In this case, one person is in AR, the other person is in VR. So traditionally we would call this asymmetric, right? Because they're seeing it from two different paradigms. If it was a system where they were all seeing it, experiencing it in AR, symmetric collaboration, or both in VR, still symmetric collaboration. There's another two terms that I didn't include here, but they are synchronous and asynchronous. So in this case, they are experiencing it at the same time. They are seeing each other at the same time while they move. This is synchronous, so they move temporally at the same time. Asynchronous would mean someone does a recording or something of something. Like let's say the movement of the guy there was pre-recorded. They already knew, oh, this person is gonna want to know where the tomatoes are. I'm gonna place a target here, and then they're gonna need to know where the sink is. I'm gonna place a target here. And then 2 days later, the visually impaired person, they put the thing on. They let's say it's like a cooking experience. So they're being taught how to cook, and like it's step by step. So they just experience a pre-recorded demonstration, right? So then it's asynchronous. So it's not temporally at the same time. Okay, it would be nice to have the audio here. I don't know how much we can. A little bit. Okay, so I can explain this because it's going to be difficult without the audio. So this was actually a project that was developed as the master thesis of a student that did multimodal last year, and they were working with a company that it's a manufacturing company. They have like big manufacturing machines, that kind of thing, and they wanted to explore how to make it easier for people to learn new procedures on these heavy machinery. You know, like how to operate or how to do maintenance on this type of heavy machinery. I'm gonna let this thing play. So they started to use LLMs. LLMs, if you don't know, is like pretty much ChatGPT. So like you are able to train it on a bunch of data. In this case, we were training it with work instructions for the company. So the LLM, the AI agent, was learning how to operate machines, and then the person can talk to the agent and understand and ask questions, and then they will be explained how to do specific things. Okay. So for her master thesis, she wanted to explore different ways to deliver this content. So here we have a little drawing explaining. So she was exploring two different variables. One was sound source. So let's say in the first one, you're getting the information through headphones. And in the second one, you're getting it through speakers embedded in a specific machine. So the specific machine that you're interacting with, you're trying to maintain. The other variable here was persona design. So what is the persona that is that AI agent is playing? So in one case, they were playing a human operator. So they talk a little bit more like a human. You have the slides on Canvas, so you can watch the video later if you want. In one case, they're talking more like a human. In the other case, they're talking more like a machine, like more robotic. And this also influenced the personality of each. So the machine is going to go more straight to the point. It's not going to greet you. It's just going to answer what you asked very objectively. And the person is going to be more affable. They're going to be more friendly. They're going to greet you. They're going to explain things a bit more, that kind of thing. So I wanted to get, let me see how much time. Okay, I think it's probably fine. So we have 4 different interfaces here because she did a combination of this variable with this variable. So let's say you get that with this with that, and then the other combinations, right? But for this, to speed things up a bit, I would say that the only thing that affects what we're talking about here, the spectrum, is the sound source. So for the sound source, if it's coming from headphones, where would you place it along the spectrum? Anyone? Yeah?
Was it coming from the machine?
So the first one, the sound sources were coming from, I mean, there's the two, but in the first case, the one coming from headphones.
Okay.
So you're wearing headphones. The headphones are not being tracked in space or anything, so the sound is going to be the same regardless of where you are.
In some ways, it just feels like the real world, since you're so used to having headphones and wearing them.
Yeah.
But like it in some ways augments your reality,
Mm-hmm.
truly speaking.
Okay.
It feels very close to.
Very close to real world. So even before AR.
Probably, maybe.
Hmm. The only virtual thing is the voice, right?
Yeah.
Cool. Now, if we're talking about the embedded speaker, so the sound is coming from the machine. The metaphor here is that you're talking to the machine and you hear the audio coming from the machine, so as if you're talking to a person. And of course, if you walk around the environment, because you need to walk around the machine to touch on different things, the audio is always gonna come from that place, right? So you're gonna, let's say the audio is stereo, of course. So if you're facing this way and the sound is coming from here, you're gonna listen more from this here. If you turn around, it's gonna come from this here, right? So in this case, where would you place the interface in the spectrum?
I feel like that's just the real world. Like if a fire alarm goes off, I'm not thinking like, oh, I'm in AR now.
Sure, yeah, fair enough.
So it's just like a thing making a sound,
Yeah,
maybe. But I also feel like you could argue that it's AR because it augments your reality and it's like a virtual or like a digital thing. The sound like tries to convey you information.
mm-hmm.
But
Anyone else? Okay, so let's say we had two arguments here. We had one very on top of real world, like the fire alarm, and the other one on top of AR, right? So who agrees with real world? Who agrees with AR? Okay, a little bit more. So my take on this, and like you said, it's debatable, right? It's an argument to be made. My take on this, I would say the audio, if we're only talking about the audio in the first condition on headphones, it's purely virtual, right? Because it has no placement in the world around you, and it's almost the same as playing a game, right? It's fixed on the little screen there. This one is fixed on your headphones, right? So I would say the audio itself is purely virtual. So I would even place it like all the way in VR. But then of course there's more happening here. Like there's the machine, there's the whole environment around you. So all in all, it's a bit hard to place. Like maybe even the real world would make sense. Maybe AR. But then the other one, when the sound source comes from the machine, my take is that the machine is being embodied. So it's representing a character, right? And it's a virtual character, right? Because a real machine doesn't speak. So you are fixating a virtual audio coming from a place situated in your vicinity, like in your actual environment. So I would argue that this is augmented reality, because you are augmenting a real component, like the machine in this case, with a virtual voice, right? So I would place it in AR. But like I said, it's an argument to make. And like we were saying before, it depends on the problem that you're trying to solve, right? But yeah, nice. It's a nice discussion there. What else do we have? Situated data visualization. Okay, so this one we were working with a company that does something called EMC. That's electromagnetic compatibility. So when you're developing a new computer, a new antenna, something like that uses a network, you need to make sure that the waves, the electromagnetic waves that it transmits, it doesn't affect other components that are already around you, right? So a very, very common case 15, 20 years ago, I don't know if you've been through this, but you're watching TV, like an analog TV, not a digital one, and you get a phone call, like a landline phone call, and there's gonna be a disruption in the signal, the TV signal. So the TV is gonna start playing some weird noise because the signal from the phone is affecting the signal from the TV, okay? So that's a electromagnetic compatibility issue, okay? So this company tries to solve that by testing the waves that a product transmits prior to releasing that to the commercially, right? So in this case, we were getting the data being read by the sensors that they had, and we were placing these in the environment around the component that they were testing. So in this case, they were testing that computer there, and this is the electromagnetic field that the thing is emitting, right? So we were demonstrating these using like a headset, so a person would see the field being drawn in all around the actual object, right? So here you're trying to like capture data from like specific places. So this is a data visualization application. In this case, we would call it a scientific visualization because we're exploring like a very objective data being read from the world. In this case, like electromagnetic field. So where would you place this visualization tool in the spectrum?
I would say that's full AR because you're augmenting the reality you have with visualizations of the waves.
Yeah, I would say this is very straightforward as well. Yeah, I would say it's AR as well. So I actually forgot the numbers, but yeah, let's do H's. Anyone disagrees? Yeah. So these are all elements that are around us, both the component and the field. Even though we don't see the field, the electromagnetic field, we know that it's there. I mean, if you believe in science. So we are making a tool to visualize that. So add that virtually in your vicinity, in your environment, right? So yeah, I would say it's AR. Now next one. Oh, I don't have a video for this. Okay, so physiological sensors during gaming. So this was a colleague of mine. She was exploring physiological sensors. So that means like reading body data, like heart rate, muscle activity, brain activity, what else? Body temperature, like a bunch of different things. And she was measuring all of these sensors when a participant was playing a video game, in this case Minecraft, right? So in her case, she was only using these as output. She was only reading the data from this experience, right? So the person was playing around, and she was reading their body sensors and collecting it for further studies with different things. So in this case, it's just output. So in my opinion, if we're only talking about output, unless you're talking about the Minecraft experience, but if we're only talking about the output of the sensors, we don't even use the spectrum, right? Because you're not experiencing anything. I mean, you might experience the discomfort of wearing this thing, but the virtual experience itself, you're not feeling anything, right? It's just output. However, we can, and a lot of people do, a lot of projects do nowadays, use these sensors to interact with the game. So you use your physiological sensors, either your brain activity, your heart rate, your muscles, to input into the game. So the same, by input I mean like the same way you press a key, you could be tensing up your muscles, you know. So this could be something in the game. So you can, and a lot of people do, use these as a input for a game, and then we could get into the sense of a spectrum analysis here. If you're using brainwaves, and there's more and more hardware doing these nowadays. So this thing is an example that gets used in research a lot. Nowadays you're getting more advanced things that are somewhat unethical as well. I'm not gonna call any names, but Elon Musk. So these are called brain-computer interfaces, right? So when you use your brain to either control an experience, or you use the experience to send information to your brain, right? So yeah, it's just I don't have a definite place to put this into the spectrum. I just wanted to bring this as a suggestion to keep an eye out for, a lookout for, because I feel like these things are going to be more and more embedded into devices nowadays. One thing that in VR people already use a lot is eye tracking. So like you measure where your pupil is looking at, and you can use that as input for a game. But more and more we get into different things as well. Meta, the Facebook company, just launched a bracelet that allows you to detect hand movements just from the muscles or the tendons in your arm. So like, because when we move a specific finger, your muscles here, your tendons actually, they move differently if you move one finger from another finger, right? So they developed this thing that you can track almost every hand movement just from a little bracelet in your wrist. So just wanted to leave this as something to look out for in the near future, because there's a lot happening with this. Next one now, motion capture. Here we have a. Can you see in the video? So this was also done here at KTH. Another former colleague of yours who did multimodal before. They had a mocap, so motion capture recording of a surgeon performing a brain surgery. So that the purple thing there is called a ventricle. And the surgery in question, the procedure, they need to pierce a hole through the ventricle. And here we are looking at motion capture data. So that is what they call a catheter. That's the thing that pierces through the ventricle. And they have it motion capture. So they have an animation of it through time. Here the user, it's actually me, they're doing playback. So like you can move forward and backwards in time. You can speed it up, slow it down. And now we're comparing it with VR visualization of the same thing. So you can see the catheter moving. You can control the frames that you're in the visualization. Yeah, so this was recorded. I don't have video for the recording, but this was recorded in a full motion capture rig. That means like a room, like a big room, with cameras all around, the same that you'd use like in cinema productions to record and animate characters, you know? So in this case, we're doing something a bit more simple in a way, because you're only tracking a catheter, but in a different way, it's more complex because it's surgery, right? So you need to be very precise of where the thing is, right? So this thing here, we would call it a high fidelity motion capture, because you need to be very lifelike. You need to be very precise on your measurements, right? So we'll only talk about the second interface there, where you're using the headset. Where would you place this in the spectrum? Anyone? Yeah?
Isn't this the same as the second example?
I don't remember what the second example was. Was it?
Was the person without power?
Okay, yeah. Yeah, I'd say it's fairly similar, right?
Then it's AV.
Yeah, it could be AV. If you want to be very technical, like the things around you that can disrupt your experience, you could place it in AV, but you could also place it in VR because you are at least the intention is to take away all of the actual environment and insert you in a purely virtual environment. At the same time, and maybe this is why you mentioned AV, the procedure that was actually recorded, right? It was done in real. It was done in real life. So for that reason, if you're talking about the motion capture data, then yeah, AV would like actually be very suitable, right? So that's actually a very good take. And at the same time, maybe I should have mentioned this now and not before. So here, at one point, the doctor, the surgeon recorded the data. A few days later, someone was looking through it. So in a way, you could call this a collaborative experience as well, but then it will be asynchronous, right? Because it's done in two different points in time. So unlike the previous one that we were talking about before, which was synchronous, right, happening at the same time, this is asynchronous. I should have added that there. But yeah, really, really good. Yeah, I would agree. AV is like a very good definition. So now a couple of other things that are also being explored by master students like yourselves here at KTH. They're also motion capture, but we would call them low-fi, so low fidelity motion capture. And you might understand why in a little bit. But this one is an application to play the piano. So here the user is playing the piano. There's sound as well, but we can't hear. The user is playing the piano, wearing a headset. The headset is recording their hand movement through time. And there you see like a rough skeleton of the hand playing the thing. The system is connected to, this is, of course, it's an electronic keyboard, a piano keyboard. And you get to connect to the MIDI. If you play instruments, you might know this. But the thing detects which keys you're pressing, so you can communicate the two devices, and you actually get a chance to see the little keys being played. Okay, so this is the other end. So just before they were recording, now they're visualizing. So on the right there is their real hand playing. On the left is the recorded hand. So this student, he was exploring the use of AR. I shouldn't have said AR. The use of this application to teach piano, right? So, you can sort of hear it. So in a way, a teacher records themselves playing. Then later on, a student puts on the headset. They are looking at their own piano, and they see the hand of the teacher playing on their own piano, right? So they're trying to make remote teaching a little bit better, because on remote teaching, usually you have like a camera set up looking at your piano, but then it's sometimes a bit hard to understand which exact key did they play, how was their fingering, they call it fingering, the hand posture, how was your fingering doing that song. So they were trying to make it a little bit more understandable by using this system. So yeah, I shouldn't have said it before, but where would you place this in the spectrum now? Anyone? No one? Yeah?
They are, they have the real physical objects and they have some sort of guidance that's not really like the event.
Perfect, yeah. Well, classic AR example, yeah. And then, because you're recording it at one point and seeing it at a different point, what type of collaborative system would it be? Perfect. Yeah, asynchronous. That's really good. Oh yeah, and then about the symmetricity. What do you think? Is it symmetric or asymmetric? Anyone? Yeah?
Probably asymmetric, but it depends. Like the teacher could be wearing the same setup, but you could also just have a mocap setup. I guess.
Sure, yeah. So in this case, there's not a mocap setup. The teacher in this case is wearing the same headset because that headset has hand tracking. So the headset tracks the hand. Does that change your...
Then it's symmetric.
Perfect, yeah, great. Exactly, yeah. So here we were exploring low fidelity motion tracking. So the hand tracking in the headset, it's not as precise as a full mocap setup, but it's pretty good. So in this case, we were exploring how accurate could it be. And in this case, the student managed to get up to 90% accuracy, something like that, by using the embedded hand tracking in the headset, right? So now, because we're in a project with this manufacturing company, we are applying the same concept to that's very laggy, to recording and visualizing instructions for a machine. So in one end, an instructor can record themselves operating on a machine, and in a different end, a trainee, so someone new to the company, they get to see the instructor interact with the machine through this lo-fi recording there. So it's a bit hard to see. The quality is not great. I don't know why. Oh, there's no quality. Is that better? Oh no, what did I do? Okay. Oh yeah, I should have just go back one. Okay. You can see, but I have a thing in front of my thing that I can't press this button. Okay. It's pretty much the same. Never mind. But yeah, like it's the same concept as the piano there, but now we're expanding it to test it on a manufacturing scenario, right? So you have the little hand there executing tasks in that case it's an actual machine, but again, like now we could explore AR on one side, VR on the other side, or reverse it. So this could be fully VR because they're recording it at their own home, like remote. The other end could be in situ, so that means like locally, and then it's AR. But at the same time, you could explore in a digital twin. So like it gets confusing, and you can mix and match what you're trying to do, right? I just wanted to show the types of things we can do with these technologies. All right, so we actually got to the end. I usually talk too much and I go over time, but yeah. Do you guys have any questions about any of the projects or any of the concepts? If not, you're free to go, or you're free to come talk to me as well. But yeah, thanks everyone. And yeah, if you have any questions about AR or VR in the future, reach out. That's my email here. Thank you.